Okay, students, today we are going to learn chapter Sound, 8th standard CBSE. We are going to discuss about the transverse wave. So, first we will see the concept. What is transverse wave? Transverse wave are those wave in which object vibrates perpendicular to rest axis. So let us understand what is rest axis and what is vibration. Suppose this is a object is like this given in the experiment is suspended from the rigid support, and your object will start vibrating from its mean position. So this vibration in this is called a rest axis, and the particle will now start vibrating after application of some force. So let us observe it using some experiment. Now pay attention. This is your bob, and this is suppose a length, and now it is a this is a axis is called rest axis. Without any application of force in equilibrium, what position is there, that is called rest axis. And now I'll apply some force, and now it will start moving, right? Left side and right side it will achieve some extreme position, and then it will come back. So from the mean position it is going left and right extremes. That means the particle is vibrating perpendicular to the its rest axis. So let us draw the diagram of displacement versus type of this graph of this motion, and let us understand in more detail about the transverse wave. So in the diagram as I saw in the experiment, you can find here that your object is performing and attaining some extreme displacement in the right hand direction and the left hand direction. So here a positive plus x, that is a maximum displacement right hand, and minus a in the left direction. In order to complete complete revolution going from here to plus a, coming back to position, and going to minus a and coming to this position, is called one cycle. And to complete one cycle, whatever time is required is called one period. So now pay attention here that the time going from here to here is, and coming from here to here is t by 2, and from again going from here to here and coming back to here is t by 2, and again that time period is divided into two parts. Going from here is half of t by 2, and going from here to here is t by 2, that is t by 4. Similarly, the path and time is here divided in two parts for going and coming. So what, t by 2 is divided again into two parts, t by 4 and t by 4, and total time period is t. So let us draw on the graph and find it. So this is the displacement of the particle. So in first t by 4, where is the particle at? Extreme, that is plus a. So at t by 4 it is at point what? Here. So I'll match here. Starting from 0 has reached this point. Now at t by 2, that means half time period here, where the particle is come back to the mean. That means it come back to the 0 displacement. Can you get it? 0. Here displacement is 0. So it's coming back to the 0. Now again from here it is going to in extreme of negative direction, that is minus. In next t by 4 is going to minus a. So next t by 4 is 3 t by 4, so it is going to minus a. So I'll just take the point of intersection of these two, and I'll find it out here. So it has reached here. Now in the next time t by 4, it has reached from extreme to the 0 mean point. So in the next time it has reached to the 0. So this is a graphical representation of transverse wave. Transverse wave, in which this part is called cleft and this part is called trough. So consisting of one craft and one draft is a one cycle, and the time period required to complete one circle is called time period. So this is the basics about the transverse wave. Let us revise once again. What is transverse wave? A wave in which object vibrates from its vibration is perpendicular to rest of axis. So here it is the rest of axis and his particle is performing here vibration. So he is performing here in horizontal line and rest of axis is here perpendicular line, vertical line. So both are perpendicular to each other. So such vibration when performed, the waveform is called transverse wave. And here we are making a graphical representation of the wave using displacement versus time graph, and we find this curve. So this is a